everyone, let's look at an application problem involving graphs of functions. So in this problem, we are given a graph, and it is telling us the flow rate of the Arkansas River in thousands of cubic feet per second as a function of time t in months since the start of the year. First thing we're looking for is f of 7. So that 7 is an input, which means on a graph it would be an x value. So it's slightly awkward, but 7 should be right in the middle of 6 and 8. And if we follow that up, it looks like we're hitting, let's see, let's count. 1, 2, 3, 4. Okay, so every tick mark on the vertical axis is 0.1. So that is hitting at 1.7. So I would say we're getting that 7 months into the year, or you could say like right at the beginning of August, that would be. The flow rate is 1,700 cubic feet of water per second. So there is my interpretation. And that 7 months since the start of the year thing is a little tricky, but if we say 1 month into the year, should be right around the beginning of February, should be about February 1st, and follow that through. That's where I'm getting the beginning of August. All right, second part here, solve f of t equals 2 and explain the meaning of our solution. So now we are being given an output, not an input. When you have an f of t equals, that means y equals. So if we look at f of t equals 2, we're going to work our way across the other way. And be thoughtful here. You do hit the graph one time, and if you're not paying attention, you might quit there. But if you keep going, you'll actually hit the graph a second time. So there are 2 answers to this question, and that is fine. If you pick an individual input, you should get exactly 1 output. But if you pick an individual output, you might get multiple inputs, and that is acceptable. That doesn't violate the function rule, that violates the one-to-one rule, which is okay right now. That causes problems only when we get to inverses. If we drop down, it looks like we're getting something a little smaller than 6. These tick marks are kind of funny on the horizontal axis. There are 5 boxes for every 2 units, so each box is 0.4. So that should be at 5.6. And then the second solution looks like it's at 6.8. So I would say the flow rate is 2,000 cubic feet per second, 5.6 and 6.8 months into the year. If you would like to translate that into like mid-June or late July or whatever month it is that way, go for it. Since it does translate a little awkwardly with months not being all the same length, and it's kind of tricky thinking through that sometimes, I also think it's okay to just say 5.6 and 6.8 months for this one. So here is my explanation for that one. Next, we're asked when the flow rate is greatest. So we are looking for a local maximum, is what we would call that, a maximum value. We haven't defined all that vocab yet, but we'll get there, and I think that one's fairly intuitive. Flow is greatest right at that peak, and if we follow that down, it's really close to the 6-month mark, maybe just to the right of that. But I would say flow rate is greatest at about 6 months. All right, and we have one more. Let's sneak up a little. Find the average rate of change from t equals 4 to t equals 6 and explain using everyday language. So we need to calculate the slope of the secant line. We need to find 2 points. So it looks like we're roughly at 4.4 and 6, 2.2. So when we calculate slope, we're going to do change in y over change in x, And it's completely fine if you reverse the order of the points, as long as you reverse the top and the bottom. So 2.2 goes with 6 and 0.4 goes with 4, and we don't want to reverse that at any point. That would be bad. So I think I'm getting 1.8 over 2, which is 0.9. So let's first tackle units with that. If you remember, we were getting flow rate and months on our two axes. So when we look at that 2.2 and the 0.4, that's the change in flow. And when we look at the 6 minus 4, that's the change in time. So that's the number of months. So flow rate is 1,000 cubic feet per second, and our time was in months, which means our units are thousands of cubic feet per second per month. So that's the units. Let's actually state that as an entire sentence. So what I'm seeing here is from month 4 to month 6, the flow rate was increasing by 0.9 thousand. If I'm going to explain in everyday language, I don't think 0.9 thousand is everyday language, so I would change that to 900 cubic feet per second. And that should give me my interpretation. So again, I think it's important to specify the time interval we looked at, 4 to 6 months. I think it's important to clarify that this is an average. So 4 to 6 months was important, average is important. The everyday language piece, changing 0.9 thousand to 900, I think that's important. And then what we're saying is that over a 1 month period, the average increase in flow rate was 900 cubic feet per second. So cubic feet per second per month, basically, should be our units on that one. All right, so watch those average rate of change interpretations. Those can be tricky. Hopefully that helped. Thanks for watching.